Good morning, good afternoon, and good evening, depending on where you are. And thank you for taking time out of your day to join us on this 1 hour Appgate SDP demonstration. My name is Jim Anthony. I run the sales engineering team here at Appgate, and appreciate you doing this with me. I'm going to run through Appgate from a technical perspective, tell you how it works, and show you some demonstration capabilities or demonstrate some capabilities of the product as we go through the next 60 minutes or so. And before I get started, I want to remind you that I will take some questions at the end. So if you've got questions or thoughts that you'd like to ask, use the questions pane in the GoToWebinar console. So if you could do that, that would be great. I will ignore them for the first part of this, but leave some time at the end so that I can answer those questions. And then I'd also like to remind you that we are recording the session. If you have any issues with that, you can probably hang up. And then the last thing is let's get started, right? So again, Jim Anthony here. Appgate SDP is the name of our product. Appgate is the name of the company. You've probably found your way here by talking to one of our business development reps or one of our sales reps. Or maybe just registered on the public-facing website. But either way, I appreciate you being here. I'm not going to kill you with a bunch of marketing slides. I'm going to assume that you've already done a little bit of research, which led you here in the first place. So let me tell you how Appgate really works. First of all, Appgate is a software product. It is a product that we deliver to our customers in the form of software. There are no cloud-routed or multi-tenant elements associated with the product. And as such, you can rest assured that your data, your network traffic, your configurations, your encryption keys all remain with you. And so that's a very important feature and big differentiator for us. That software comes in the form of two footprints. One footprint is on the end user's workstation. It is a client. That client can be deployed with programmatically with software distribution tools. It can be deployed manually by end users themselves, i.e. go to a download page, download it to the install. So there's all kinds of options on how you get that client deployed. Today we support Windows, Linux, Mac OS, Android, and iOS operating systems, as well as Chromebooks. So it's a very, very broadly acceptable platform or software product for most all of your end user activities. This client can also be deployed on servers to be used to control traffic inside of data centers. So think about an east-west use case inside of data centers, call it microsegmentation. So in that regard, we use the same software, the same product to do not only north-south, but also east-west. And then speaking of the client, we also make an appliance that has the client preloaded on it. We call it the connector. That connector can be used in an IoT scenario as well. And so the idea that IoT devices, you're not typically able to install client software on an IoT device because it's locked down. It's got its own operating system. It might be running on some other technology. So with our connector technology, where it's basically a client in a box, and that box can be physical or virtual, by the way, we can use the Appgate software in an IoT play as well. So that's the first component, the client. The second component is an appliance that we deliver to our customers that runs in the data center or the network where the protected applications live. That appliance, again, can be physical or virtual. From a physical perspective, I'm happy to sell you a server that, it's a 1 U-Tall pizza box. You take it out of the box, you rack it, you stack it, you stick some power on it, you plug network cables in, and it does its thing, right? That's one option. I would much rather give you my virtual machine version. So from that perspective, the virtual machines are free. The licensing model it facilitates the deployment of virtual machines, as many as you need, within a licensed data center. We'll talk about that later. That's one of the licensing components. But as soon as you license a data center, you have the ability to deploy as many virtual appliances as you need to achieve any level of scale or throughput that you desire for that particular data center and the applications that live in it. And so that appliance in its virtual footprint, we support many different hypervisors, including VMware, OpenStack, KVM, Hyper-V, Citrix Zen, Oracle Box, and as such, we also support all the major cloud infrastructure as a service providers like AWS, Azure, GCP, even Alibaba, Oracle, Oracle Cloud, and some others as well. So all of those platforms are supported, and we can run our Appgate software on any of them without an issue. And so the first thing to think about, if after you get your hands on the software, you get it licensed, the first thing to think about that's really different about Appgate, besides it being software and not cloud routed, is that each of those appliances that we deploy in the environment are protected by something that we call single packet authorization, or SPA. SPA is a concept that allows you, the customer, to create your own key, and that key is deployed to your end users and embedded in their client and is used to unlock the network interface on those appliances. In other words, the end user starts communicating to the appliance by first sending that SPA token. That SPA token is analyzed to make sure it's a proper token, it's still a valid token, it hasn't been tampered with, it's coming from a device, the same device that's sending it the traffic, so there's no man-in-the-middle replays and things like that. But the bottom line is, if the user doesn't have the SPA token, or it's an unknown, unauthorized user without your SPA token, then that appliance is going to completely ignore any attempts to communicate with it. That renders it unfindable on the network. This is a huge differentiator between Appgate and most other technologies, any other technology really, because no other commercial product that I know of has embedded this type of capability into it. What that means is that there are no open listening ports associated with my appliance unless you have the SPA key. If you have the SPA key, then a dynamically built open port is allowed to communicate with the end user, and when that communication is done, that port's closed down, and it's only allowed to take traffic from that particular end user, that defined source where that SPA token came from. So it's a really big differentiator, and it literally hides the front door of your data centers. If you think about how I'm describing this, it hides that door. So if you don't have a key, the door doesn't even make itself visible. Unlike any VPN that's out there, unlike any firewall with an open port to a service running in the DMZ. And so that's an important concept to think about. So under the covers, that Appgate client will exchange the SPA token with the controller. This is a function of an appliance. That controller will then validate that SPA token, start listening, say, hey, I need your login request, send me your credentials. The end user provides those credentials to the Appgate client. Their credentials flow up to the controller where they're actually validated against your identity management system. So here, I am not an identity management provider. Appgate does not provide identity management in and of itself. However, we integrate with any LDAP, SAML, or radius-based solution that you may already be using. That means we can integrate with your Active Directory, your Azure AD, Ping Identity, Okta, Duo, Jump Cloud, Centrify. The list is long, right? But anything built using SAML 2.0 or Radius or LDAP, we can generally integrate with and have access to attributes associated with that user's identity if they provide a proper password. And so now we begin to get access to information that goes beyond the username and password, and we call these claims, user claims in particular. The user claims can now be stored in Appgate and used as variables to define policies. The Appgate controller also reaches back down to the Appgate client running on the end user's device and basically says, I've got some posture checking that needs to happen. So there's a bunch of things that happen under the covers automatically, like give me the list of IP addresses of every network interface on the device. Give me the default gateway's IP address. Give me all of the MAC addresses of all those NICs. What type of OS are you running? What version is it, et cetera, et cetera. But then there's also a lot of customization that you can do there too. So with Appgate, you can actually tell the controller to query that device and look for anything that might be in the file system, anything that might be a running process, a service, a registry entry. And once we know the OS, we can actually tell it to execute certain scripts on the platform as well. Those scripts are what you write to pull any level of information that you could get from a command prompt. So imagine writing a script that might pull a certificate name out of the certificate store to validate that this is actually the corporate issued device and it has a corporate issued cert on it. Just query to figure out if the cert's actually present and what version it is, things like that. So completely customizable. The idea here is this posture checking can be used to determine the health and the trustworthiness of the device itself. Is your hard drive encrypted? Is your local firewall on? Is the antivirus running that we installed because it's corporate issued, et cetera, et cetera. You control all of that, and you decide what those posture checks actually look like. Again, all of that info flows back to the controller, stored in variables. We call these variables device claims and network claims. So now, combined with the user claims from the identity management system, you can really build complex policies that would allow you to completely control the idea of building trust from the ground up every time a user connects. So now I could literally say, you have the SPA token, you have your username and password, I know what groups you belong to, I know the health of your device, I know what network you're on, therefore I'm going to grant you access to certain applications that are related to your position in the company. And that's what a policy looks like within Appgate. At this point, the controller will decide which policies you qualify for, bundle those up into something we call a live entitlement file, and send that live entitlement file down to you, the end user. That live entitlement file is received by the Appgate client, opened up. Of course, it's encrypted and the end user doesn't have direct access to it or anything like that, but it is encrypted and opened up by the client. It contains lots of information. First of all, it says, look, I've been granted access to certain IP addresses, certain DNS names, whatever. All of this information gets put into the end user's route table as a way to drive traffic to those destinations into the encrypted tunnels that are about to be established. The Appgate client also has information in that live entitlement file that says, look, these applications live in certain data centers and they're protected by certain sets of gateways. It randomly selects a gateway for each data center and attempts to reach out to that gateway and establish a connection with it. Of course, the first thing it does is sends that SPA token down, says, hey, I'm a known trusted user, pay attention to me. It's analyzed by the gateway. The gateway says, yep, that's the right SPA token. I'm listening. What have you got to say? The Appgate client then sends down that live entitlement file. The live entitlement file is sort of, think of it as the passport, allowing the end user access to something that gateway is protecting. The gateway will take that file and say, yep, it looks like a valid entitlement file. It came from the right device, the device to which it was issued. It came from the right user, the user to which it was issued. It came in an untampered format, so it hasn't been changed or modified by that user, and it still lives within the TTL that's associated with this particular entitlement. Everything checks out. So I will, as a gateway, I will terminate a secure encrypted tunnel between the end user and myself, the gateway, and I will establish a ephemeral session-based micro firewall within the gateway itself, and put the rule set in that micro firewall, allowing that user to access that destination based on the entitlement. So we might grant TCP port 22 access to that application, or maybe it's UDP port 53 because it's actually a DNS server that is the application. So there's a whole host of different protocols that we support. Again, much broader protocol support than any of our competitors out there. And the point is that they go into this firewall rule, and that firewall rule is used to further restrict what the end user has access to inside of that data center, allowing access to the things that the passport, the live entitlement file, grants access to, but blocking access to everything else in that network, preventing lateral movement, preventing unauthorized access to other applications. And again, this is built dynamically and maintained throughout the session. In fact, speaking of the session, if something were to change, Appgate is monitoring the environment, senses that change, and if that change predicates the changing of what the user is allowed to have access to, then Appgate would modify that user's ability to reach those destinations, maybe remove something or add something on the fly. The end user doesn't have to log out and log back in. It doesn't have to refresh in any way. It all happens automatically under the covers for the end user. And then, of course, we can multiply that picture by any number of data centers that the user might be granted access to, building simultaneous multiple encrypted tunnels from the end user's client out to all those different locations. Those locations can be different platforms, different cloud environments, different data centers, completely different architectures. It doesn't matter to Appgate. In fact, you can have virtual appliances running in some places, physical appliances running in others. Some can be cloud, some can be your physical data center, doesn't matter. And so thinking about using this access method, obviously there's a major use case associated with remote and third-party access. You can use Appgate to grant access to applications no matter where the user sits, whether they're sitting at home or in a Starbucks. And part of that posture checking can include modifying what they have access to based on where they are. But also, of course, the end users can use this on-prem as well. So when COVID-19 is over and we all go back to work and end users start showing up at offices, this same access method can be used inside the network where the end users sit and do their work, the office space, if you will, even if the data center is sitting right down the hall. A lot of our competitors have cloud routed solutions that would force that user out to the internet before they get back to that data center. With the Appgate solution, I'm leveraging any layer 2 network that sits between the user and the data center. That can be the LAN or anything else, all the way up to and including the internet, a MPLS circuit, an SD-WAN, even a point-to-point circuit or a direct connect from any of the cloud providers. Doesn't matter. We're going to directly route that end user to all those different locations based on this patented multi-tunneling capability. So let's dive into it. That's the end of the slide deck for now. I'm going to end it, and let's pop out here and let me show you these different components and how they work. So I'm running a MacBook, and you can see here this is my Appgate client. I've exposed the fact that it is Appgate. I've authenticated as Jim against an Active Directory. I was posture checked and evaluated, and trust was built with me and my laptop and my network. And as a result, I was granted access to applications that live in 6 different data centers. And you see all those data centers represented here in the graphic. This was dynamically built as I logged in. And then down below, you see some quick launch icons. These are actually application launching icons that they will launch whatever app is installed locally, but give me access to specific destinations that are being protected by Appgate. So for example, I could launch this AD server RDP. It launches whatever tool I have installed on my local machine as a remote desktop tool, which happens to be the Microsoft Remote Desktop software, and it connects me to the protected asset, 10.66.2.4 in this case, on port 3389. Let's just see if I can log into this thing. So I got to accept the certificate, right? That's an exchange going on between me and the desktop machine itself, the virtual machine. And so there it is. I've logged into that Windows box. Maybe I was managing DNS the last time that I was in here, so I've got that screen up. Maybe I want to back up here and look at all the different servers in the network, whatever, right? And so, but easy enough. You can see that I'm actually reaching this Windows desktop from my MacBook that happens to be running in Microsoft Azure. No special, browser-based RDP tools or browser sessions that are associated with this. I'm using native TCP port 3389 to reach this application. And so what that means is that I actually have a route in my route table to that destination. And remember, that was 10.66. Something. Let's go see what's in that route table, and just quit that desktop tool there. And if I display my route table locally, this was managed and modified by Appgate after I logged in and was granted access to certain applications. So you see all these different apps that are listed going to Uton 2. These are actually being controlled and managed by Appgate. And in fact, 10.66.2, I think it was 2.5 or 1.4, something like that. I can't remember the exact IP address of that RDP server, but the point here is that I've got routes to various different servers in my route table that are being forced into the tunneling driver that is my Appgate client, and the Appgate client sorts out exactly which tunnel to send the traffic down. In this case, when I RDP to that desktop, it sent it to Azure, Iowa, where there was a set of firewall rules for me, for my session, and it granted me access over port 3389 to reach that destination. I can just as easily launch maybe an S3 bucket. This happens to be a JPEG in an S3 bucket that's being protected by Appgate. So I was granted access to that quote unquote application as well, right? So Let's dive a little deeper into this Appgate client. Let me show you something else that's kind of interesting. So as I look at my About screen, you can see the type of Appgate client. It's a full version. We also have a skinny down version that does just web stuff. Here's the version number that I'm running. Here's the controller that I've authenticated against, my identity provider I used, et cetera, et cetera. Let's dive into the list of entitlements. I've got a couple of entitlements out here that are in London, actually in my AWS London environment, and I call them London PHP Server and London PHP Server Elevated Access. So I was granted access to this PHP server in a couple of different ways, 2 different entitlements, same destination, but allowed to access it in different ways. So first of all, I've got in one of the entitlements, I've got an action that says allow TCP up to 10.205.2.247/32 on port 80 under the condition always. What does that mean? Let's break it down a little bit. So first of all, I can do allow, block, even alert actions on certain destinations. What this means is that I'm actually allowed to, this is a firewall rule that's going to allow me to reach a destination. I could just as easily very explicitly block certain things. But remember, Appgate is a default deny solution. So if I'm not specifically allowed to reach something, I will be denied access to it. But the allow and blocking allows us to create some interesting overlapping entitlements. Imagine a scenario that I could actually create a block for an entire subnet, but then an allow for a particular IP address in that subnet. So in the Appgate world, it's not a matter of sequence of which is the predominant entitlement. It's actually a matter of which is more specific. So in that scenario where I'm blocking a subnet but allowing an IP address, it would work exactly as you think it would. No access to any IP address with that one exception of what I was specifically allowed access to. Alternatively, I may have another scenario where I'm granting access to an entire subnet, but blocking a particular really super important server. And so that would work as well, right? So I could grant access to a subnet with an allow and then block a certain IP address within that subnet. Easy enough to think about. Next idea here is TCP. Yes, TCP is a protocol that runs on top of IP. We support lots of other protocols, many more than any of our competitors, including ICMP, UDP, GRE, AH, ESP, and others. Just about any protocol on top of IP, if we don't support it today, we can add it to the support stack, give us the right reason to do it, right use case, and we'll be happy to add it in. Up is another concept. So with Appgate, I have the ability to control both an up direction to the data center resource, as well as a down direction from the data center down to the end user's device. So think of perhaps when COVID-19 is over, I'm going to go into the office and I'm going to work from the corporate environment. Maybe with Appgate, I sense that the user is on the corporate LAN. He's got a very fast connection between the data center and the LAN. So maybe in that scenario, I want to issue a down entitlement, allowing the backup server to reach into the end user's platform and issue a backup command, start a backup and stream a backup up to that backup server. But when they're working from home, I don't want that interruption, or I don't want that end user to have to pay for that bandwidth of consuming a backup while it's flying over the internet, right? So I wouldn't want to give him that entitlement when he's working outside of the office. The next idea here is the IP address, and notice first of all it's a private IP, right? So this is typically not routable, but we insert it into the route table and actually control access to it. It can be a /32, it can be a subnet, it can be a /24, /16, whatever you want it to be. Obviously, a /32 is a very specific IP address, one place. It could also be a DNS name, right? And we'll resolve that DNS name, both a public DNS name as well as a private DNS name, and can be a public IP address. So we can control access to a public IP address. And if you're going to do that, you need to think about the settings on the public IP address destination and the idea of whitelisting the Appgate gateways that are controlling that access. So think about, say, Office 365 or Salesforce.com. If you want to control access to a SaaS-based offering or a public site that you don't necessarily own and operate, then you need a whitelisting setting within that public offering that allows that control and locking down access so that it comes only from gateways and not from the general public internet. In Office 365, that is called conditional access that you can configure in your Azure platform. In Salesforce.com, there's actually a whitelisting, a trusted source IP setting that you can use. And most of the others have these same concepts as well. Port 80, I could just as easily put a comma there and add 443, and I could put a 1-65.535 and grant access to all TCP ports, all kinds of different options there. And then condition always. So think of the condition as the status of that micro firewall that's associated with the user session. Condition always implies always on, right? Always up. So the firewall rule is up and available. I should be able to access port 80 to that IP address without any issue. But notice my elevated access entitlement down below here has a different condition that's requiring a default OTP and a completely different set of actions that are built for it. This includes SSH as well as ping in terms of ICMP as the protocol. So if I pull up my browser and browse to this thing, I should be able to get there without a problem because of the condition is always. Let's give it a shot. There's 10.205.2.247. The traffic was captured by my route table, inserted into the tunneling driver. The Appgate client knows which tunnel to send it down. It arrived at the gateway that's protecting access to that London EU West 2 environment, where it was taken out of the encrypted tunnel, passed through the micro firewall, and then hit the resulting EC2 instance on port 80, and it responded to me in the reverse, came back. So this is a resulting page. I've got a Linux AMI that's running out there. It's got a PHP service on it, yada, 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 right? It's been up 452 days, whatever. Nice, a nice stable little platform there, right? Simple application, right? I hit a web service. But if I go back and think about this other one, what about this condition always, or this condition default OTP? What does that look like and how does that work? Well, notice that it's ping, right? So let's try to ping the destination and actually see what happens. If I pull up my command prompt and ping 10.205.2.247, what's happening here? Well, ping's running, and it's running. Looks like it's running. It doesn't necessarily look like it's running completely successfully. So that could be a little issue. Well, why is that, right? Well, it's because that last minute condition actually hasn't been met yet. And so Appgate is actually giving me a warning message. Notice my Appgate icon changed a little bit. And if I didn't have my do not disturb enabled on my desktop here, I would have gotten a pop-up, right? So it's interacting and saying, hey, this has been triggered by this elevated access that you're trying to do, and I need a one-time password from your Google OTP key. So let's see if I can pull that up. So I'm using my iPhone here. I'm not going to be able to share my screen on my iPhone with you, but I'm pulling up Google Authenticator. I'm finding the right OTP key, and currently that number is set to 793.976, and it's about to change, so maybe that's going to work. Yep, and it looks like it accepted it, and look at that. My ping suddenly starts to flow. I'm getting return packets from that ping command because I satisfied that OTP, and Appgate changed the status of that firewall to an up status instead of a down status and allowed my traffic to flow through. So ping is actually working, and at this point I could SSH to it because that was also part of that same entitlement. But the point here is that with Appgate sitting between the end user and the protected asset, acting as a gateway and a termination point of that encrypted tunnel, as well as a firewall granting access to that specific thing, I can actually use that method to interject any kind of condition, whether it's a multi-factor or a step-up authentication, or even double checking that his antivirus is still running, or even all of those things. I can even do hard tokens plugged into the USB port. I could do CAT card readers, you name it, I support it. Bottom line is I can do that with any application sitting on the other side of the gateway. So now you can do multi-factor or step-up authentication to your mainframes or your AS400s or those other legacy apps that you don't have the time or the money or the willingness to go in and modify so that they're poking your users for multi-factor. So we can get you to that multi-factor status for every single app in the environment if that's something that you choose to do. Hopefully that makes sense. So now I've showed you two little demos. One demo was me just directly accessing RDP using a local RDP tool. Another demo was using multi-factor to do step-up authentication to allow me to actually ping an asset. Let's dive into another unique capability of Appgate. I mentioned earlier that Appgate gives you the ability to define destinations based on IP addresses as well as DNS names. We have a third way to do it as well. We have a concept called metadata-based access. So here you can see some special entitlements that I call QA team. This one happens to be in Amazon Northern Virginia, and the actions are ICMP along with some TCP, but let's just focus on ICMP because we can very specifically see when that access is granted. But the destination here is defined as an AWS tag of mode equal QA. What does that mean? Well, if I go into my AWS console, I can see here I am in Northern Virginia. Let me turn on my little finder here. You can see that I'm in Northern Virginia, and these are all my EC2 instances I have there. I happen to have down here toward the bottom, I have some QA instances that are running. QA1 in particular, 10.201.4.176, and he has a tag of mode equal QA along with a bunch of other tags. So mode equal QA, that seems familiar. Let's go back and look here. Look at my Appgate client. Mode equal QA. So that means that 10.201.4.176 should be in my route table because it meets that query. Let's go and validate that. So here I am, route table, fresh new look, 10.201.4.176. Sure enough, there it is, right there in my route table. And so that means, based on that entitlement that we just looked at, I've got ICMP access to it. I should be able to ping it. So there it is, ping's working, it's flowing. I'm sitting in Southern California, that thing's in Northern Virginia, so I'm pinging all the way across the country. Ping times aren't spectacular, but there's a lot of distance involved there. But there they are, right? So ping is working great. Well, you may have a question in your head. Well, so Jim, that looks interesting. That tag is changeable. What happens if it gets changed, right? I could manually change it. I could programmatically change it. Let's just simulate a change. Maybe we've promoted this thing to production, right? What happens now? It no longer meets the query that Jim was assigned to. Well, Appgate realizes that it no longer it meets that query and changes my ability to access it. So it removes the route from my route table and it changes the firewall rule in the Appgate gateway that my tunnel is terminated on. And it changes it, removes it completely. So I no longer have ping access to that thing, and you can see my ping is failing. I didn't have to log out, log in. I didn't have to do anything special to make that happen. Appgate senses the change and knows that I was assigned that entitlement and modifies my ability to access it. And likewise, if I were to go back from an unaccessible perspective and change it back to a way that it does qualify for me to access it, the reverse becomes true. Appgate senses that I now qualify to see it. It adds the firewall rule, adds the route in my route table, and off I go. My ping still works. I don't have to refresh or log out or anything like that. So very dynamic. That's why we call it a live entitlement. Appgate can monitor just about anything. I've just showed you it monitoring a tag, but we can monitor, whether or not my antivirus is still running, whether or not I'm still in the same geolocation, whatever, and make sure that everything is true that you want to be true before the user has access to it. And if it changes, we can remove access on the fly, so to speak. All right, another interesting concept, that's the third little demo that I've given you. Another interesting concept is Appgate has the ability to integrate with any other system via API calls. So Appgate is an API first software solution. Everything that we do involves API calls, even the admin console that I haven't even showed you yet. But let's dive into how this works from an API perspective. I've got a ServiceNow console. Let me see if I can log into this thing real quick. And I apologize for not having it prepped and ready to go. So here is my ServiceNow dev instance that I've got running. I'm logged in as Jim Anthony. These are the incidents and tickets that are assigned to Jim at this point. Notice that I've got a target field here. So these are the IP addresses of the things that Jim, the system administrator, needs to actually go work on. Well, within my AWS environment, I've got some really special servers. I call them management servers. These are locked down. Jim shouldn't have any access to them unless there's an open trouble ticket. So let's pick on one of these, 10.201.4.18. If I go look at ServiceNow, notice I do not have an open trouble ticket with that IP address. Again, let me turn my mouse locator back on so you can see. No 4.18 listed in here. That means, based on everything I've showed you, that we should not find 4.18 in my route table. Let's go see. So here I am, 10.201.4.18 is not in my route table, right? So I don't have a pathway to that destination, and that means if I try to ping it, it's going to fail. My computer doesn't know where to go, request times out, whatever, right? So let's just let the ping continue to flow. So what we've done is we've set up an API integration. If an open trouble ticket exists for the destination and it's assigned to the user that's logged in, to Jim, then Jim will be able to have access to it. So let's go and simulate that. Let's create a new trouble ticket. Please help me, fix my server, whatever. Let's assign this to Jim, and let's call it 10.201.4.18, right? So we're going to submit the ticket. So now there is an open trouble ticket. Here's my list of tickets. 4.18 is in progress. What happened under the covers now is ServiceNow issued API calls back to the Appgate controller and created an entitlement, created a policy, assigned it to Jim, granting him TCP and ICMP access to the destination. So if I Alt-Tab back over to my ping, you can see it's actually already started working. That API call, that set of API calls, resulted in me being granted access to that destination. And again, if I break out of the ping and do a netstat again, we'll find that 10.201.4.18 was dynamically inserted into my route table. And that's the beginning of understanding how we're capturing that traffic. A firewall rule was also created, granting me ICMP access to it, and so on. And so I'm going to start my ping up again, just to show you that it's working. But before I go and do anything tricky with the ticket, I want to show you what happened in the Appgate console. So here, notice that I have an incident number of INC 0010220. So let's go into the console, and I'll show you some more details about this in a second. But let's go look at the policies that were created. Let's look for 220 as an example. That was the last couple digits of that trouble ticket. So the API integration actually creates a policy on the fly and names it snow_Paul_ and inserts the ticket number. And so there's the exact ticket number that was created. You can see it was created just a couple of minutes ago on today's date. Let's look at the details of it. So here we can see it is enabled, and it is assigned to when any of the things below are true. And this is the distinguished username is Jim, and he authenticated against SDP demo AD. Well, if I go back and look at my Appgate client, you can see I am Jim, and I authenticated against SDP demo AD. So this is assigned to me. And so if the user is that, then let's give him access to this entitlement. So that entitlement looks like it was also created dynamically by the API call. So let's look at the details there. So this, again, is in AWS Northern Virginia. It's allowing TCP access to that particular destination on port 22, as well as ICMP access. Condition is set to always, so there was no multi-factor or anything else required. It then forced Jim's tokens to refresh, telling the Appgate client that it should go out and take a fresh look at the things Jim's been granted access to, and that's what resulted in the route getting put into my route table and the token being exchanged with the gateway with the new firewall rule popping up. And so all that happened programmatically under the covers. Again, ping's still running, right? So what happens if we go and close the ticket? Let's go and simulate it. So here I am clicking on my ticket, fix my server. Jim, he's done a great job, good job, thank you. go about your business. Let's resolve the ticket, right? So the point here is when the ticket status changes to resolved, the API call is made back to Appgate, removing the policy, removing the entitlement, and forcing Jim's tokens to renew. That removed the route from the route table and removed the firewall rule from the gateway. And suddenly Jim no longer has access. Completely programmatic, no logging out, logging in, or anything refreshing from the end user perspective. So there's the fourth little demo. Let's kill the ping and pop over to the console. And I promised I would walk you through a few items here. So this is the dashboard associated with the Appgate world that I have deployed. Again, private to the customer. So this is my Appgate instance. We call it a collective when you have multiple appliances. So I've got 24 appliances in my collective. 19 are acting as gateways, 2 as controllers. I've got 1 log server and 1 IoT connector as well. As I scroll down here, you can see all the different gateways in the environment, their status, their function, the different numbers of sessions that they're currently handling, CPU, memory, network, and disk utilization. This will help you with vertical scaling of the appliances, given that they're virtual machines. You might want to, add more RAM or more CPUs to get more throughput, depending on the types of apps that you're actually using there. And then notice I've got a version number out here. This is an Appgate version, the version of the software that's actually on the platform itself. And then on some of them, I've got a little C in parentheses here. This denotes that I've got a customization running on that appliance. So here at Appgate, we give you the ability to create what are called appliance customizations. And then deploy those customizations to all of your appliances or subsets of appliances. This gives you the ability to actually deploy agents or other software onto the appliance. And knowing that they're virtual machines and knowing that we run in cloud environments, you can also deploy these appliances in auto-scaling groups on those platforms. Combine auto-scaling with this appliance customization feature, and now you've got the idea of programmatically deploying agents, call it a Splunk agent or a SolarWinds agent or other things, Datadog agent, for example, that you might be using to monitor and manage those EC2 instances or those Azure instances, whatever. You can do that programmatically. You don't have to do it manually as you spin up and spin down different environments. So that's what customizations is all about. Scrolling a little further here, you can see DNS names that my end users are using to resolve applications. Some of these may be internal, some of these may be public, but the point here is I could quickly click on one as an administrator and gain access to a very quick and easy create an entitlement screen on a particular IP address associated with a DNS name. That's an interesting feature that you can use to actually ratchet down the security of the environment. And then over here on the right, I've got top entitlements, so you can see some of the most popular entitlements that my end users are using. And yes, we can provide protected access to Office 365, whether it's Exchange or SharePoint or Skype or whatever, we can certainly do that. And here you can see the remapping of a user's default gateway as well. So beginning to blur into that SASE model, we can control how a user accesses the internet. And if you want to layer on other technologies that do blacklisting or whitelisting of web addresses or groups of web addresses, you're more than welcome to do that. We don't do that inside of Appgate, but you can direct end users traffic to those solutions so that they can do that whitelisting or blacklisting of internet traffic. Scrolling a little further down, I've got my active sessions here. So you can see I've got a couple of servers that are logged in, and this is that east-west use case I was mentioning earlier. I've got people that are logged in as well, and I can see how they authenticated and what some of their device IDs are and things like that. And then a little further down, I've got some IoT sensors as well that are running, and I'm using Appgate to control what those sensors can do on my network and sensing if they deviate from anything that's out of the norm, then I'll have the ability to take action, whether it's terminate them or allow them to write to a bit bucket or something. I can take action on it in that regard. Out here to the right, I can see the licenses that I've consumed. Appgate is sold on an annual subscription basis. The cost of the licenses are based on people's identities and data centers where your apps are deployed. And so there's a couple of hidden statements in there. As a user, I'm a human, I'm a person, and I have an identity in an identity management system. I might also have 5 devices that I want to use to do work on, a laptop and an iPad and whatever, right? In the Appgate world, I'm still one license consumed. I'm one user, no matter how many devices I have, no matter how many clients I'm using, I'm still one user. From a site perspective, we think of a site as a collection of subnets that are generally protected by a single ingress point from the internet. So think about a VPC in Northern Virginia. There could be multiple subnets in that VPC, public and private subnets, doesn't matter. That's one site from an Appgate perspective. That VPC could also be connected to another VPC using peering. That's still one site as far as Appgate is concerned. On the other hand, you might have another region where there's no peering connecting those regions. Now you're talking about two sites. Physical data center, typically one site, right? So that's what sites is really all about. And yes, we also support the idea of using transit VPCs, transit gateways. That would be one site, no matter how many different connections you have to other VPCs. And so, there's some architectural challenges there, architectural things that you can think about. Using a transit VPC gives you the ability to reduce the number of sites you need to license from Appgate, but it also introduces potentially unnecessary hops for your user traffic. So you figure out what the right approach is in your world. Scrolling a little further down, you can see user logins per hour, statistical information about my particular environment, and then new devices onboarded per hour. So you can see some different information there about new devices that my users are using. Diving a little deeper into it, let's go back and let me show you some information about the posture checking real quick. As I looked at my list of active sessions here, these usernames are all links to a detail page about that session. So here I can see information about the network that the user is connected to. I clicked on myself, for example. So this is from my AT&T internet service. You can see the geolocation of where I am. I'm in California. There's more than just those three pieces of data that are in the log, and I'll show you that as well. Scrolling a little further down, here's information that came from Active Directory about my user identity. And again, here's that distinguished username field that we keyed on for that open trouble ticket. Here's all the groups that I belong to. And again, these values are stored in variables that we call claims. That variable can now be used to build policy. Scrolling further down, you can see device claims. So here's all of my IP addresses for all the network interfaces that I have on my machine, my CPU speed, the presence of certain software applications that I want to check for, et cetera, et cetera. Running Mac OS 10.14.6. I can even see the name of my Wi-Fi and the strength of my signal and the transmit rate of that Wi-Fi. Yeah, I need to check into why it's very slow. That's not appropriate. So anyway, all of those can be used. They're stored in variables. So let's go take a look at what it looks like to actually build a policy. So here's my list of policies that I have in the system. Let's add a new one. We could call it Gym Test or whatever, but here's where the rubber meets the road. If I add a new assignment criteria, now this is where all my variables pop up. So remember that groups field that I showed you, SDP demo AD groups. I can validate that, the user is a member of the IT admin team, right? Whatever, right? He's a member of the IT admin team. And if he is a member of the IT admin team, I want to make sure that, it's Monday through Friday, because I don't want this guy working on the weekend, so I could do something like that. I could make sure that, maybe his, I don't know, let's pick something interesting here, right? So maybe we're going to make sure that his Wi-Fi transmit rate is, is not very slow, right? Right. Maybe we do that. But maybe I also want to make sure that he's running an antivirus. So let's Cylance happens to be our critical antivirus here. So I've got a Cylance check for Win, because the Cylance executable on Windows ends with a .exe. And I've also got a separate Cylance check for Mac, because on a Mac, Cylance executable, like any other executable, does not end in a .exe. So I've got two different checks here, but now I've created a scenario that will never be true, because I'll never be running the .exe version as well as the non.exe version. So this gives me the ability to go in and apply some custom logic. So I want to make sure that first of all, the user is a member of the IT admin team, and he is working on Monday through Friday, and his Wi-Fi transmit rate is not very slow, right? And he's running either Cylance on Windows or Cylance on a Mac. And so now I've created a scenario that will allow my IT admin to log in on either a Windows or Mac machine, but I'm going to make sure that he's running Cylance as the antivirus before I allow him to do anything. If he meets all those criteria, then he'll get access to all the things listed in client access. So think of this as a big and statement no matter what. So maybe I want to give him access to everything in AWS Ireland, for example. And maybe also I want to give him access to, say, everything that's tagged MS Office. And maybe I also want to give him access to some very specific entitlements, like maybe this one and maybe this other one, right? Whatever those are. And so I've now created a pretty complex little policy, but it took me a matter of like 30 seconds while I talked you through it. And so every time somebody logs in, all of that posture checking will happen, and they will be bounced against this policy. And if they qualify for it based on these 5 criteria, then they'll be granted access to all these things, and all those things will appear in the entitlement list for that user. And that's how simple it is. You may be asking, so that's all interesting stuff, but can I look backwards over time and see who's logging in and what they're accessing? The word is absolutely. We include in our product a Kibana-based ELK stack, and we make that ELK stack available to each of our customers. All you have to do is define a log server as one of your appliances, and it will start collecting logs from the other appliances in your collective. And so here you can actually see all the different logs over the last 24 hours. In fact, here's Jim with an IP access log. Let's take a look at the details here. And yes, it is a Microsoft Office 365 Exchange action that's happening. So my Outlook client is running on another screen, and it's reaching out automatically to try to get new email addresses. Here's that same IP address that I showed you from my AT&T provider. Here's the destination that I'm trying to reach. Yes, it's a public IP. But I've got my Office 365 environment set up using conditional access, allowing only authentication requests coming from an Appgate gateway. And I told you there was more information about the geolocation. Here you can see the city that I'm in, the continent that I'm on, my geo coordinates, both in a longitude and latitude perspective, et cetera, right? All kinds of information right there in the logs. I also have the ability to use Appgate to feed any logging system you may already be using. So we can use a typical log feed scenario. If I go into System and just click on any random appliance, you can actually see in Networking Advanced that I have our Syslog Destinations. This is a pretty complex one where I'm actually doing a regular expression selection based on audit and event types equal IP access. I'm feeding them through a template, adding the host name of where that log came from, as well as the message itself. And I'm feeding it to a UDP-based destination, 52.39.4.157 over port 44442. Presumably on that IP address, I have a Syslog server that's receiving that information and categorizing it, indexing it, et cetera. And I'm not a Splunk expert, but that's one of our Splunk servers that we've got up and running. And so I can actually create multiple Syslog destinations as well. So I could feed different types of log files to different types of Splunk services if I wanted to do that. That's very easy to do as well. And then there's even a third way we can do it using that appliance customization. I could use it to install a Splunk agent and use the Splunk agent to capture the logs locally and feed them wherever I needed to feed them. All right, that's sort of it. I was going to show you some more, but we're running out of time. It's about 7 minutes until the top of the hour. So let me page through the questions. We've got quite a few in there. The first question that I see is, will the session be recorded? Yes, the session has been recorded, and we'll send out a link to the recording soon. The next question, can we replace firewalls with Appgate? Well, so the answer to that one is sometimes yes, sometimes no. Everything that I've described, you can think about Appgate replacing firewall functionality that controls end users' ability to access applications. So you can simplify firewall rules that sit on the edge of your network, creating potentially just one rule, allow anybody in the world to talk through your firewall to a Appgate gateway sitting inside your DMZ over TCP 443. That's the port and protocol that the tunnel uses. Now all of your end user traffic can be directed through that single rule in your public facing firewall, and let Appgate sort out who has access to what on the back end. That public facing firewall rule drastically simplifies all of your end user rules that are in that firewall. You still need that firewall to control access to the general public, because remember, the general public is not going to have an Appgate gateway or an Appgate client on their installed machine. That is something that we're working on, a browser-based Appgate client, a browser plugin, if you will, or even a true clientless scenario that does some other things. We're working through some of that, future features, so just keep that in mind. So we don't replace public-facing firewalls, but we drastically reduce the complexity of those firewalls as far as your end users accessing applications. Next question, hopefully that answered that. Can we have one webinar where only an installation is shown and setup? Hey, that's a great question. So basically, can we have a webinar where we do an install and a setup of Appgate? And the answer is, yeah, that's something I can do. So stay tuned for something in the future. We can do that and get the recording out there, and I'm happy to do that. Next question. So I haven't read ahead on this thing. I'm going to read it in real time, so forgive me if I go crooked on it. For single point authorization through controller, will there be any overhead in networking? What are the advantages of over a VPN? What would be the major integration challenge replacing SDP instead of using a VPN? What's ROI? That's a lot of questions. What's the ROI for replacement? So 100%, Appgate is used to replace VPNs all day, every day. Couple of things that make us unique and different over a VPN. First of all, remember my slide where I showed the multi-tunneling. In fact, this would be an appropriate time. I can pop it back on the screen. So the first thing to think about is a VPN only gives you one tunnel. That one tunnel creates all kinds of weird things in your environment that you have to deal with. Either you have to teach your end users to connect to different VPNs because they need access to different apps, or you have to provide back-end connectivity between the data centers where those apps live. That can be a problem either way. Second thing is that single tunnel creates a bottleneck entry point for all of your end users. Given that we're all in lockdown or self-isolation or whatever you want to call it because of COVID-19, there's a lot of companies out there that are realizing that their VPN infrastructure was designed and deployed for a subset of their user population. And now they have to get every single employee over that VPN infrastructure, and they're dying. Go and look in Twitter for hashtags like VPN rationing, and you'll find interesting posts by employees of Cisco, right? Imagine that, and other companies that create their own VPNs. So they're actually having to ration end user time on the VPN concentrator because it doesn't have the capability, the bandwidth, the throughput to handle every employee simultaneously. And I think I've demonstrated to you that with Appgate and auto scaling and horizontal scaling and vertical scaling, not a problem for us. And multi-tunneling actually solves a problem of your internet connection itself running out of capability. So now you don't have to worry about your pipe being flooded because everybody's coming through the same pipe to the same concentrator. Another unique capability you have Appgate over a VPN is that single packet authorization that I talked about. With single packet authorization, I'm hiding the open listening port from unauthorized users. VPNs don't do that. There's an open listening port on the internet at all times with any and every VPN concentrator. They can be found and therefore they can be hacked. That's a problem. And so ROI is a complicated question to answer. Should we include the cost of recovering from a breach because of your breached VPN in that ROI calculation? If yes, then the ROI is astronomical. We'll be net positive in 0 time if you include cost of breach in that scenario. And so anyway, think about that as an option. So obviously Appgate is not free, but it also isn't expensive. It is, if you're interested in getting a quote or understanding a pricing model that would fit into your environment, please reach out to your sales rep or your business development rep, and we're happy to work with you to make that happen. All right, I'm moving on to the next question. Those were a series of great questions there. So here's the next one. Does this support NAC integration or have any of the 802.1x controls for L2 control of IoT and IoT devices? Yes and no. So here's how I typically answer the NAC question without thinking about the question that you asked specifically. Appgate is not a NAC. We do not have 802.1x in the platform. However, let me rephrase the question and answer it in a slightly different way. Let's think about what a NAC does. And by NAC, I mean Network Access Control Solution. Cisco ICE as an example of a NAC. First of all, NACs do two primary things. They control every single port of the network that your users are sitting on. So if anything gets plugged into the port, that NAC solution is there listening to the port, the physical port or the wireless port, and it understands that something got plugged into it, and it analyzes it, and it determines whether or not it should trust it. Is it a trustworthy device? Is it a type of device I know? And if it is, how should I classify it? And this is where the second thing comes into play. And what should I allow it to have access to? Therefore, what VLAN do I put it on, right? Well, that's interesting. It's an interesting thing to think about, but there's a couple of problems with that scenario. First of all, in order for the NAC to listen to the ports, the user has to be on a network controlled by the NAC. Well, all user activity, especially user activity today, users aren't on NAC controlled networks. They're sitting at home, they're sitting in Starbucks, they're sitting at airports, they're working from anywhere and everywhere. And so now you have to force the user to get back onto the NAC based network and do unnatural acts like VPN back into the network. And now you're back into the VPN scenario. And so you need a NAC oriented solution that does client posture checking anywhere and everywhere. And that's what Appgate does. No matter where the user is, we check the client posture all the time, no matter where they're sitting, no matter what network they're on. So that's the first thing. Second thing, NACs require special technology at the network layer, i.e. in the switch, in the router. In Cisco's case, that means you got to have Cisco gear in all of your locations. Cisco gear doesn't exist in AWS or Azure or GCP. Can you really use the NAC to its fullest capabilities on all platforms? Probably not. Third, are you in an M&A mode? Are you acquiring other companies? If you have a NAC and they have a NAC and it's a different NAC, how are you going to integrate them? How are you going to get them to talk to each other? Most likely you're going to have to go swap out one of the NACs for one that you want to use and integrate them from that perspective. Extra cost, extra time, extra issues. So the Appgate answer when it comes to NAC is no, we're not a NAC, and no, we don't want to be a NAC. And I would tell you, I would argue with you that your NAC is actually a waste of time and a waste of money. What we do is posture check the end user no matter where they are, and instead of dropping them onto a VLAN in the data center that gets big and hairy and complex to manage, we grant them very specific access to applications based on the entitlements that I showed you. So that's my NAC answer. Next question, and I know we're over and I appreciate everybody hanging on, but let's run through it. Is it possible to control what AWS account I can use to access like a CASB can? Yes, the answer is yes. I can control access to the AWS console, and I do it with a combination of things. So think about the AWS console as an application as a service. So I can go in and configure that AWS console to make it available only to certain trusted source IPs. And those trusted source IPs can be my Appgate gateways. And so that's the bottom line. If you can define a whitelisted trusted source IP for a SaaS offering, and the Appgate console could be thought of as a SaaS offering, then we can certainly control access to that destination. Next question, what are the on-premise deployment requirements? Will there be any application to be integrated into the data center network? On-premise deployment requirements are literally gateways. You need to deploy these gateways as appliances, and I've talked about them both being either physical or virtual. So if you've got a hypervisor that is accessible from your DMZ, then you can deploy virtual machines all day, every day. The controller needs to be one of the functions on those appliances, and that the only real requirement for the controller is that it needs network access to your identity management system. So if your identity management system is Active Directory and it's sitting behind the firewall, that controller just needs access to that Active Directory. If your identity management system is some cloud-based SAML offering, then your controller can literally sit anywhere. It can sit in AWS, Azure, GCP, whatever. So it doesn't matter. You can even put the controller in AWS if you have an Active Directory, as long as there's a pathway for that controller to reach into your environment and directly query your Active Directory. That's the only real requirement. And there isn't really any other integration with any data center networks or any application tools. You don't have to integrate it in that regard. You don't have to deploy the Appgate client on your application servers themselves. You can if you want to control east-west traffic, but you don't have to. So there's hopefully that answered the question. Next question. Let me get to the controller will be taken care of on all the policies managing part, whereas gateway will be in front of all the application, get access to the customer. Am I correct? Yes, you are correct. So let me run through it again. The controller function does the authentication and authorization for your users, and it assigns policy, assigns entitlements through policy to your users. From there, the controller's done with the end user interaction until something changes or the end user needs to provide a multi-factor or something like that. But the controller functionality is kind of done for a while. From there, the gateway is actually what controls access to the application. So we've separated the control plane from the data plane, just as the software-defined perimeter specification calls for in the Cloud Security Alliance's spec. So 100%, you are correct. Next one, can we integrate with a DLP? Answer is yes. So think about a DLP for a second. A DLP operates at layer 7. Right? So a DLP is actually looking at the application and looking at the data and controlling what the user can do with that data. Can I download the data? Can I screenshot the data? Do I have the ability to make a copy of the data? That's really what a DLP is doing. Well, Appgate doesn't operate at layer 7. We operate at layer 3 and 4. But before I grant you access at layer 3 and 4, I can make sure that that layer 7 thing is running, right? I can make sure it's there to do its job. And if it suddenly goes away, then I can stop your access at layer 3 and 4. And that's the power of posture checking and the power of us doing our thing at layer 3 and 4 and a DLP doing its thing at layer 7. Okay, hopefully that answered that question. Next question, as we can place multiple gateways in different sites, so how they are connected and each other, how is the controller controlling the gateways? Great questions, right? So back to my picture here, I've got different gateways running in different environments. How are they connected to each other? How does the controller talk to them? Fantastic question. So we actually open ports between all the appliances on TCP 444, allowing them to communicate with each other. So the gateways will reach out to the controller and say, hey, I need an encryption key, or I've got a multi-factor request here. Can you go validate it? Stuff like that. So yeah, TCP 444 is required to communicate between all the appliances. In fact, if you have multiple controllers in your environment, we also require TCP 5432 so that we can replicate the database running between the controllers so they run in a hot scenario. So yeah, great question. And I think that's the last one. Yep, so let me advance the slide here. And I think those were fantastic questions, and I appreciate everybody hanging around and talking about those, hanging in there with me and going a little bit over here. If you're still interested, and I hope you are, in experiencing more about Appgate, we do have a free test drive. You can pop out to the URL on the screen, testdrive.appgate-sdp.com. Register for an account, use your corporate email, don't use a Gmail or a Yahoo or whatever, and certainly don't use an AOL. Don't ever tell anybody you still have an AOL account. But yeah, so pop out to the test drive, register for an account. We'll send you an email with credentials based on your corporate identity, as well as a URL that you can click on and actually log in and experience the Appgate environment. If you don't want to actually do the test drive, but see somebody else doing, it's actually a video-driven system as well, so you can watch pre-canned videos that we have out there of somebody else doing that test drive. His name is George, he's a great guy. And that's it. So I'm done for the day, and I appreciate everybody hanging on. Great questions, by far some of the best questions that we've had in this entire series of videos. And stay tuned. We'll get working on some other ideas. Maybe we'll do a series of deployment videos, some other interesting demonstrations and capabilities of the product. That's it for me. Thanks, and stay safe and healthy, everybody.